Hello, good day. My name is Zayan Koff from the group Mozambique, and we are about to present to you our study entitled Identifying Accidents Pattern, a Descriptive Analysis of Car Accidents in Metro Manila. So let's start off with the table of contents. So the first one is the business understanding. The second part of the presentation is the data understanding. Next is the data preparation, the modeling, and finally the evaluation. So for the first part is the business understanding. I'm going to explain to you the objective of the case study. Uh, the first objective is to understand the complex factors that lead to the accident in Metro Manila. The second objective is to analyze the various aspects of traffic data to anticipate significant improvements in road conditions throughout Metro Manila. And for the business questions, for the first business question is the which specific travel directions experiences the highest frequency of accidents in Metro Manila? The second question is what are the specific cities within Metro Manila that tend to have the highest vehicular accidents? And the last question is during which specific time period do we observe heightened rates of accidents? And for our methodology, the techniques employed in our study is descriptive data mining. Taking this method made it possible to gain a thorough understanding of the elements that contribute to car accidents in Metro Manila.
So next is chapter 2, which we're going to be talking about is data understanding. So as the researchers, we utilize Manila traffic incident data set, which we obtained through Kaggle. So characteristics of our dataset is its extensive selection and user-friendly interface make it valuable resource for researchers like us, particularly students, as it provides access to datasets at no cost. So it's very free and very accessible at all times. So here we have the dataset. So it's 1 to 13,000 actually. 13,000. Phew, takat na lang yun. So next we're going to be talking about the columns or attributes that are inside our dataset. So we have the date, which is when the incident occurred. So its data type is nominal. So the time is the incident, also the time. So when it happens, so it's also nominal. Then the city and location. This is where the incident occurred, but the difference is the city is categorical while the location is only text data type. So next we have the latitude and longitude. They're both numeric. The high accuracy attribute is categorical, which is the indication of accuracy level of the location data. So direction is related to incident. Example for north, if the vehicle is going northbound or southbound, so it's categorical data type as well. And the type of incident, so we only have one, which is vehicular accident, so it is categorical. So the next ones are lanes block, which is number of lanes blocked due to the incident. So its data type is numeric. And the vehicle involved, which talks about the details of the vehicle or entities involved in the accident. So it's text data type. And the tweet source of information, so where we got the accident information, so it's also text data type. And the source, which includes the URL link of the original post or of the tweet or news article or whatever, so it's also text data type as well.
For data preparation overview, the Metropolitan Manila Development Authority, or MMDA, has said that traffic accidents in Metro Manila reached their highest point at lunchtime and the afternoon rush hour. They are recommending drivers to verify that their cars and physical condition are in optimal condition before getting behind the wheel. The MMDA system data indicated a substantial surge in road collisions between 2017 and 2019, which is vital for devising traffic control strategies. An analysis was conducted on collision data spanning from 2016 to 2020, revealing an upward trajectory in accidents until 2019. The research identified drivers as the major casualties, with automobiles and motorbikes being the most often implicated vehicles. The researchers diligently purified the data by eliminating unnecessary items and missing values to improve the accuracy and relevance for analysis. For data preparation, as you can see our overview of our data set. We ran a scan through the information to make sure it was full and there were no blanks. And here confirming there are no empty values, we made sure that the list did not have any null or empty numbers.
In this study, the computational platform that was utilized throughout the modeling phase was Google Colab. This platform provided a collaborative atmosphere that was conducive to the completion of data analytic endeavors. With the use of descriptive data mining techniques, the researchers investigated the dataset titled Traffics in Metro Manila and extracted significant insights in order to discover widespread accident patterns and trends. Taking this method made it possible to gain a thorough understanding of the elements that contribute to car accidents in Metro Manila. As a result, stakeholders were provided with information that could be put into action, which enabled them to develop targeted strategies for enhancing road safety measures throughout the city. The first step in the analysis was to organize the accident data according to the direction of travel of the involved vehicles. This process is similar to categorizing accident reports by the cardinal direction north, south, east, or west, in which the drivers were traveling at the time of the collision. The researchers then used statistical techniques to determine the total number of accidents within each directional group. This led to the creation of a summary table that highlighted the distribution of incidents among the different travel directions. To gain a clearer understanding of the data distribution, the researchers created a bar chart that depicted the occurrences of vehicular accidents categorized by travel direction in Metro Manila. The x-axis represented the travel directions northbound, southbound, eastbound, and westbound, while the y-axis showed the number of accidents associated with each direction. The height of the bars corresponded to the frequency of accidents recorded for each travel direction, allowing the researchers to readily identify substantial differences in accident patterns across the various directions. The initial task was to organize the accident data into categories based on the city in which event took place. Assuming the accident reports were ordered by the city, the researchers created separate files for each of the cities in Metro Manila. They then used statistical methods to count the number of accidents within each city's specific file, producing a summary that provided insights into the distribution of incidents across the different cities. By analyzing the heights of the bars in the chart, the researchers were able to easily identify the cities in Metro Manila with the highest number of vehicular accidents. The metropolitan area with the tallest bar represented the location with the largest number of accidents, while the cities with shorter bars indicated regions with lower accident rates. This graphical tool offered a straightforward and effective way to assess the distribution of vehicular accidents across the various cities in Metro Manila.
And next, for the timestamps in the column time, we converted the timestamps into decimal time format. How it works is basically 1 represents 24 hours. So for example, zero point 0.5 means 12 in the afternoon. We did that so that it would be easier to analyze the time ranges that experiences frequent accidents. Here is the code to show the mountain plot of these timestamps and the number of occurrences. This will be helpful to better visualize the result that we are looking for. And here is the mountain plot and how it looks like. We can better analyze which time of the day have the most frequent occurrences of vehicular accidents. For evaluation, we will be analyzing this in depth.
Hi, I am Carl Kennedy Flores, and this is our presentation for the evaluation. Now, we have three business questions which we will effectively answer during during my time. So, in our evaluation, we will see graphical data and representation of what we have gathered. The study found that Quezon City recorded the highest number of road crashes in Metro Manila, accounting for a third of the total incidents in the region. This can be attributed to the presence of major national roads and highways such as EDSA, C5 Road, and Commonwealth Avenue that cut through Quezon City, which has a larger land area and higher population compared to other cities. Later, we will see why this affects our first business questions because of the direction of where cars come from. Thirdly, is the high concentration of busy roads and increased social and economic activity within Quezon City's central business districts, contributing to the disproportionately high number of vehicular collisions reported in the city. Another factor is that the dataset that we used in MMDA strictly or explicitly uh, watches national roads only. So most of the things that MMDA supervises or uh, see is national roads. Okay, so moving on. Now, what you see in this first figure is a simplified table which shows the directions that cars come from. Next to it would be the number of vehicular accidents occurring in those particular directions. Now, EB, NB, SB, and WB are short for eastbound, northbound, southbound, and westbound. Now, what we can observe here is that NB or northbound have the highest occurrences, which is no coincidence since northbound vehicles are mostly from Quezon City and Mandaluyong, which mostly comprises of national and major roads with the most frequent amount of vehicles in it. Now, again, we should take note that the dataset we used are from MMDA and they mostly or usually supervise national roads. Okay, now the second highest number of vehicular accidents would be in southbound or SP, which have cities coming from Makati and other major city as well, which again comprises in major roads and national roads as well. Now, much like our first table, this second table would be more particular about the number of vehicular accidents occurring in each cities. Earlier, we were talking about northbound directions and southbound directions. Now we can see the actual numbers in these particular cities. Now, the first leading accident, the first leading number of accidents occurring would be Quezon City and Mandaluyong, which are from the northbound directions. And then the next would be Makati City and Pasig City, which would be in the southbound directions, which makes our data or the table that we've made naturally related to each other. Now, the data analysis reveals a clear pattern where Quezon City, with its extensive national roads and high car frequency, leads significantly in road crash incidents, emphasizing the impact of urban infrastructure and traffic volume on accident rates. Mandaluyong and Makati City's position as the second and third highest in accidents, respectively, further support the correlation between urban development, road infrastructure, and the frequency of vehicular accidents in Metro Manila's prominent cities. Okay, so this is where it gets a little bit more confusing since we're dealing with time. To give more context, our third business question is whether or not time correlates with the amount of vehicular accidents occurring throughout the day. Now, our objective here is to figure out a specific point of time where accidents occur more frequently. Now, we can talk about the solution we came up with to more accurately define the data we gathered when dealing with time. The researchers developed a decimal time system to accurately depict the peak times for accidents, aligning the time with the exact occurrence of accidents to show the frequency throughout the day. In figure 12, which is the graph that you saw earlier, uh, they evaluate the most prominent accident times, resembling morning and evening rush hours in traditional work settings, with accidents peaking during these periods and gradually decreasing afterward. The analysis highlighted 7:12 a.m., which is seen in this figure, which or zero point 0.3 in the decimal time system as the morning rush hour and 0.65 as the second highest time for accidents, defining consistent peak accident times during these periods. Now, in our conclusion, after showing you how we answered our three business questions and the graphical data that we've seen, we can now move toward defining a detailed analysis of accident patterns during morning and evening rush hours, providing valuable insights into consistent peak accident times, offering crucial information for enhancing road safety measures and urban planning strategies in Metro Manila.
And that's it for our presentation. Again, we are Group Mozambique, and thank you for tuning in.